Hello and welcome to second semester. Sorry I'm not there today. I wish I was, but my son has a fever, so I'm home with him today and I hope to be back tomorrow. So we're going to start this semester talking about proportional relationships. So the first thing we talk about is a constant of proportionality. Basically, all this lesson today is going to be putting your y value over your x. So the constant of proportionality is the ratio of y over x. And this is where x represents the independent and y represents the dependent. And we're not really going to need to worry about that too much to start with, but we will be representing the constant of proportionality with a k. So that k equals the constant of proportionality. Okay, so when we look at this first table, we've got x values and we have y values. On these tables, the x values should always be the first column or row, and the y values will be the second. And we just need to put y over x. So we just have to do 6 over 1, 12 over 2, 18 over 3, 24 over 4. And if that keeps equaling the same thing, that means we have a constant of proportionality. So we can see that this is going to keep equaling 6, which means our constant of proportionality is 6. And it also means that this is a proportional relationship. Okay, we'll do the same thing on this next table. Just put your y over your x. So this is very similar to when we were finding unit rates, just dividing. Okay, and we should see that that will keep equaling 5/10 or half. So our constant of proportionality is 5/10 or half, and that is a proportional relationship. So, as I've just told you, a relationship is proportional when the ratio of y over x is equal. Always the same. A relationship is not proportional when the ratio of y over x is not equal. So if any of these right here ended up not equaling 6, that would mean we do not have a constant of proportionality and we are not proportional. Use the equation y equals kx to represent proportional relationships. So basically today all we're going to be doing is plugging in our number, whatever we find for our constant, we're going to plug it in there if we need to write an equation. Okay, we're going to look at these situations. Now, I don't really like how this table is set up. Typically, we'd have time be our x, but we're not going to really worry about, some of these tables are set up, I would say, wrong, but we're just going to do what I told you to start, that x is our first row and y is our second. So we're going to put y over x, 5 over 2, 10 over 4, and 15 over 6. And we should see that that is going to keep equaling 2.5. So k equals 2.5. Our constant is 2.5. We do have a proportional relationship, and we can represent that with our equation y equals 2.5 times x. Okay, just plug in that 2.5 into the equation we talked about. All right, next one. We're going to put 5 over 3, 10 over 4, and 15 over 7. And we should be able to see after working a couple of those out or just looking at it that that is not proportional. We are not going to keep getting the same thing. Got it? Okay, go ahead and pause the video. Here again, we're just going to call this our x and this our y. Go ahead and work those out in groups or partners, whatever you want to do, and then we'll come back and see how you did. Okay, so again, we're just going to put our y over our x, 30 over 20, 60 over 40, 90 over 60, and each time we divide, we should get 1.5. So to plug that into our equation, we just put y equals 1.5 times x. So we do have a constant of proportionality. We do have a proportional relationship. Next one, 30 over 25, 60 over 60. Well, I can tell right away those two aren't equal. So that is not proportional. We cannot write an equation for that. All right, while training for a marathon, Keith's watch reported the number of calories he had burned at each mile marker. The data is shown. Is the number of calories proportional to the number of miles? What is the constant of proportionality of calories burned to number of miles? So we've got to keep putting y over x. I'm going to do it off to the side here. And if you plugged all those into your calculator, you would see that you would keep getting 117. So 117 calories burned. So we've got our constant of proportionality is 117. Write an equation to represent the relationship. So we use our equation y equals kx, and we plug in that 117 times x. There's our equation. The next day, Keith ran 7 miles. How many calories did he burn? All right, so we've just been given a value for x. If we wanted this table to go on to 7, what would our answer be for calories burned? So we've got an x value. We can just plug that into our equation. Y equals 117 times 7. Okay, and if I remember correctly, that is going to equal 819 calories, or calories burned. If Keith's watch reported that he burned 1,170 calories, how many miles did he run? Okay, now we've been given a y value. If we look up at our table, we'd see calories in the y row. So we've been given this y value of 1,170 equals 117 times x. And I can solve this just by using what we know about solving one-step equations. To get x by itself, I need to divide because this is 117 times x. I'm going to divide by 117 on both sides. 1,170 divided by 117 is 10 miles. Okay, so now we're going to be filling in a table ourselves. Now this is the only one where I'm going to switch things around. I think this should be our y and this should be our x. The money amount should have been listed second. On your homework, you can just know that on your homework on Class Kick, your x value is always going to be your first value and your y will be the second value. You won't have to think about it like this. Okay? So if Andrew earns $18 per hour for mowing lawns, is the amount of money he earns proportional to the number of hours he spends mowing? Write an equation and explain. So to fill in this table, we know that he makes $18 for 1 hour mowing lawns. So if I want to know how much he makes for 2 hours, 3 hours, 4 hours, I just need to do 18 times 2 is 36. 18 times 3 is 54, or I can just add 18. And I'm going to get 72 here. So, in order to write our equation, we need to know what our constant of proportionality is. So I gotta do 18 divided by 1, 36 divided by 2, 54 divided by 3, 72 divided by 4. Or we could just know that that was moving by 18 every time. Those are going to keep equaling 18. Our constant of proportionality is 18. So we're going to plug that into our equation. Y equals 18 times x. And if you're told that you need to explain if it's proportional or not, you would say, yes, it is proportional because y over x keeps equaling 18. Okay, go ahead and try the got it. We can pause the video, work with a partner on this. Okay, this one is a little bit different. Let's read it. Uptown Tickets charges $7 per baseball game ticket plus a $3 processing fee per order. Is the cost of an order proportional to the number of tickets ordered? Write an equation and explain. Okay, so again, this time I'm actually going to make cost our y and tickets ordered our x. So the question is, what's the cost of one ticket? Well, it's $7 for a baseball ticket, but we have that $3 processing fee. So if we buy one ticket, that's actually going to cost us $10. Now we only have to pay that processing fee once, so we can just add 7 to find out how much it would cost for 2 tickets, 3 tickets, or 4 tickets. Then we're going to put our y over our x and see that those will not equal the same thing. So the equation is actually going to be this. More on that later. Don't worry about it right now. We'll just say no, it is not proportional because y over x is not equal. All right, thanks for sticking with me for video notes on this first day back to school. You're going to get on Class Kick right now. We're still on Chapter 1, Unit Rates and Proportions, and we're going to do slides 9 and 10.